over to Benny. He's going to talk to us about performance and science.
Thank you, Neil. And thank you for inviting me to come over here and, be in between a British audience and lunch, putting a German speaker between that. That was a great idea. That was a great idea. Just blame it on me. Yeah. Okay. I'll be talking about digital workspace myths. And some of them will be very familiar to you. And I'll be talking about science. And this is the disclaimer here. So this session is going to be based on scientific principles. And I got to tell you, I have many customers, when I present them what I do, they ask me, whoa, how did you have that idea? And I say, it wasn't me, because I'm a physicist. And you know, physicists do that kind of principles since 300 years. And so it wasn't me. But in IT, that is different. So that is not regarded as a science, classic science, and that is the biggest challenge. So some of the content may be disturbing for you, because for the first time, some of you will be able to see what end users see. Coming back to the point that John just made, I like the idea of inversion. I took notes. Because this is something that I will also be covering. So, I'm Benny Tritsch, and this is what ChatGPT thinks I would look like if I was an Avenger. Yeah. You can't do that anymore. Because if you try to create an image of yourself or of any person, a real person, it doesn't do it anymore. Because it says, no, cannot take real people. Because people were misusing that a lot in the past. So I'm a performance data scientist, and sometimes I feel like a cameraman on Discovery Channel. Because what I do is I try to see what's happening out there in the wild and record footage in a scientific way. And hey, I have a nice quote from Bill Murray as Dr. What was the name? Venkman, Dr. Venkman. He said, "Back off, I'm a scientist." That's something that I want to use here in my session. Good. First, disturbing pictures. This is what a user sees when a remoting protocol doesn't work as expected. That's a video, and you see there are these artifacts. And most EUC admins have never seen that, because they are managing the backplane, not the front end. And when users see that, or even that, that's not a psychedelic picture. This is really what's happening on the screen if the video codec goes wrong. So I had a long conversation with Denis Gundarev, who used to be the product manager for the RDP protocol, and now is the product manager for the NICE DCV protocol at Amazon. And he educated me that this happens if you're losing the keyframe of the video, because after the keyframe, there are delta frames. Now, if there's no keyframe, but only delta frames, it's this smearing across the canvas. This is the effect. Now, can you imagine the conversation between an end user and support desk when this is happening? I have an effect that looks like I'm on drugs. What kind of drugs did you take? Oh, yeah, can I have some? Yeah, exactly. So this is another one, like the striping effect. Another thing that's not easy to see in a environment where you have LAN performance and where you have well-managed client devices. But if you're out there in the wild, as I said, or if you simulate the situation out there in the wild, then these are the effects that you may be able to see. Or something like that. The water was supposed to be blue. I call that the shark effect. There must be blood in the water. What happened is that the color lookup table was not created properly, so that means that there's a false color in the water while rendering the fishbowl. Or that one, it's just a PDF, scrolling through a PDF, and these are the effects that users may be able to see. Well, again, try to describe that in a support call. Well, this is kind of simple, but on the back-end side, if you look at your monitoring systems, everything is green. Because if the application starts, it doesn't use any CPU, it doesn't use any GPU, it doesn't use any memory. So all the monitoring folks in the back-end, they will say, wow, great performance of our service. Unfortunately, not so great performance or user experience for the end user. And because I was trying to explain that kind of effect, I had to put together a glossary. So you see these block boundaries that we saw in the beginning, the striping, the smear artifacts, the color artifacts. It took me a while to find those terms, and they are being used in the media industry, in the film industry, because they are, well, they see these kind of effects. I mean, if you have a subscription to Netflix, sometimes you see these block effects. So if your kids at home are streaming their video games and their stuff, then you want to watch a Netflix stream, and you may not have enough bandwidth for that. And so you see these artifacts. This is a big change to what we had 10 years ago. 10 years ago, users were never exposed to that kind of effects. They didn't know those artifacts. Today they do. So they may tell the support person, hey, this looks like a weird Netflix video now. Okay. So this is why all these terms are interesting or important to know if you want to analyze the environment. Now, talking about the digital workspace myths. Let's go through those. We only need to collect performance counters on the host side if we want to know how good the digital employee experience is. Wrong or right? The client specs have no impact on remote desktop performance. John, that's your thing. Remoting protocol A is better than remoting protocol B across all graphics formats. Like HDX is always better than RDP. That's one of the myths. Newer CPUs means better performance. Only network bandwidth matters. Some applications run slower in GPU-enabled virtual desktops. And 90 frames per second is the minimum required refresh rate that you need. Now, guess which of those myths are true and which are wrong. It's only one that's true. That's that one. I have applications that run slower on GPU-accelerated VMs than they do with CPU only. So this is not a myth. I have evidence. I can prove it. I can reproduce it. All the others, I call BS. Because there's always an exception to one of those. For example, the HDX protocol may be one of the best protocols in the market, but it's not always the best. There are scenarios where other protocols outperform HDX. And so I started my little initiative a couple of years ago. Today I call it DEX for DAS. And it says you can only score and optimize what you can measure. So we want to use the scientific way. In the background, you see a picture from CERN. This is where I did my master thesis. I am a high-energy physicist, and I did my master thesis at CERN. Basically, what you see in the background is like a picture, a photo of an event, like in a collider that the particles collide, and then they create that kind of patterns that you and scientists are able to investigate. So it took 10 years to build the experiment and another 10 years to analyze the results. Fortunately, in our IT industry, things go faster. So, and my mantra is, please look ahead. This is why we need science, because if you don't know what's in front of you, you may fail miserably. Good. So what are the success criteria, the quality criteria? And it's not the performance of the CPU, because the end user, they don't care what the CPU performance is. They don't care how much memory is being consumed on their machines. It doesn't matter to the end user. So they want to know how long it takes to log on. They want to know how long it takes the application to load, the user input delay, the graphics API that are supported, the media formats, if the media is distorted, and we have seen some examples. Screen refresh rate is something, if the applications are stable. The screen resolution, which is easy to measure, so most people should know. And you should also see the effects if your session is stable or not. Not only the application, but also the end user session. So these are the criteria. And to be honest, they are not easy to measure. That is the biggest challenge. This is why monitoring vendors don't cover those all. It's almost impossible, because you need to look both at the endpoint and at the host and at the network and find out what the real user experience is. Not only taking pictures, but going a little bit further. So, what is our industry? What are the moving parts in our industry? So, from a remoting client, we connect to the remoting host, and then we interact. So, transmitting the mouse data or keyboard data takes some time. Then we need to process and render it. Then we need to capture and encode the information in the virtual screen, the frame buffer on the host side. Then we need to transmit the screen data, we decode it, and we need to display it. Wow, many places where things can go wrong. And that is the biggest challenge. I did projects with the GPU vendors, with NVIDIA and AMD. And when you talk to these people within the vendors who are responsible for the gaming consoles, like every third sentence, you need to remind them, you know, there's a network between where things are happening and things are displayed. Because they don't take that into consideration. They always think, oh, it happens inside the device where everything is displayed. And I mean, looking back when the TV was invented, people were trying to look into this box, how these little people were able to interact or to do something inside the box, because it was so hard for those people to understand that it's a remoting technology, TV, very early on. Good. What are the performance influencers? And you will not be surprised that it is, again, like a spectrum. The host system, the VM type, for example, makes a big difference. Client devices, to John's point, GPUs, network, and in particular, the network gives us a hard time. Yeah, we have bandwidth, and we believe we can just book more bandwidth and everything is going to be good. You remember the myth was, oh, if I have enough bandwidth, everything is going to be fine. Wrong, because we also have latency and we have packet loss. And in particular, latency, it's Einstein's fault. He found out that, there's a speed of light. So it takes 130 milliseconds for the light to go around the globe. Unfortunately, we cannot use the speed of light for that because we have physical cables and they reduce the speed. So we have 200 milliseconds if we would not have any refresh, components on the way, because we cannot send a signal around the globe without refreshing the signal quality. So we will add more latency to that. So this is why we see all the latency when we connect to a cloud data center. So it's just physics. It's just how nature works. And we cannot beat it. Guess why Google, Amazon, Microsoft, and all other cloud providers are building data centers around the globe? I mean, the mission is to bring a data center as close as 30, 40, maybe even down to 20 milliseconds to every person on this planet. Wherever is a market, let's build a data center that's not further away than 20, 30, 40 milliseconds. Because if the network contributes 30 milliseconds plus all the decoding, encoding, and all the other processing that we've seen previously, that adds up, and that gives us problems when interacting with the system. So, how can we measure that? And measuring it is science. So we really need to use scientific methods to find that out. So we ask questions, we put together a theory, a myth. So this is the starting point. And then we need to build a test with an experiment and run the experiment and analyze the data. Then draw our conclusions. So here, cause and effect. So if I modify something in my setup, what is the result going to be? So if I change the client device, what is the effect going to be? And we need to build a lab that allows us to run reproducible tests. That's the scientific method. Like I said, invented 300 years ago. And we need to create an expert report. This is very time-consuming. This is where I spent most of my time, building labs, running the experiments, and in the end, putting together reports. And this is a typical lab setup. This is my lab when we did idle testing. So there are thin clients here on the table, and the idea was to test different. When you decided that you not want to build your own hardware anymore, and you decide that you want to work with partners, and our job was to find out how good the performance is on the different clients using the IGEL OS. This is what we did in this very moment. And we took a picture, and this was a presentation that we did at E2EVC. So building this single user test lab, you need a primary device. So the endpoint, you connect to a system under test, and then you connect a frame grabber, a video recorder to that, and record those videos. So not only screenshots, but entire videos, 60 frames per second, full HD, so that you really see what the user sees. You need to install a couple of applications so that you can reproduce the same kind of tests again and again. And this is exactly what I built. It's the EUC Score toolset. And I put a WAN emulator between the primary device and the system under test, which allows me to reproduce network conditions that I receive back from my customers. Because if I bring my WAN emulator to a customer and put it between any of their clients in their headquarters, connecting to their backend also located in their headquarters, if I have the right specifications, like, only this bandwidth and this packet loss and this latency, I can simulate the conditions that end users working from home have using the data that the networking team collected in their routers and their switches and their VPN appliances. So they have the data. Now we put it into the WAN emulator, and for the first time, those who are managing the systems are able to see what their users are seeing. This is eye-opening for some of these admins. They have never seen that before. Like I said, this is why I started with the disturbing screenshots. This is what they see for the first time. And I may add a so-called click-to-photon device, which allows me to initiate a user interaction and measure the time that it takes until the screen refresh made it to the endpoint. This is why the click with the mouse to the photon that goes into the human eye to see the change on the screen. We measure that time. It's called lag. And lag is something that is, well, not what users want. And sometimes I use playbooks. Sometimes I cannot simulate the applications. So I together with customers, I create playbooks, and they manually click while recording and while collecting the telemetry data on the backend side. You see there are CSV files and reference files. The CSV file represents performance counters. The reference files, they represent activity files. User clicked on this button, including a timestamp. So I have this information, and now I can see with the screen recording how long did it take until it made it to the screen. So sometimes it's not possible to completely 100% simulate that. So we use real users as robots. And they do it, following a playbook. Ruben Sprout, who was mentioned before, he is working for Digital Frame, and I work a lot with him. He came up with this idea. This was one of his requirements, because he said, I have scenarios that we cannot simulate so easily. We cannot create something like an autoplay thing that represents this behavior, because sometimes we just have to wait long enough until a certain element shows up on the screen. If we have to do that programmatically, this will take us weeks. And I only want to repeat that kind of scenario 2 or 3 or 4 times. So I do it manually. So he said to me, you make sure that you're able to record all of these activities in the same way as if you had completely simulated workloads. So this is my gallery of simulated workloads. You can go there, just look at it, eucscore.com/gallery. And but I added these custom or manual sim loads with real user playbooks. So this is something that I did there. Now, if we really want to see those results, because that was all the theory behind all the science being used, now we need to visualize it. Okay. So we feed the videos, the screen videos, and the telemetry data into a HTML5 player that was prototyped by a very talented Dutch web developer. So he created the prototype for that, and I built on top of that. And that allows me to analyze everything that I recorded or that I collected, all the data that I collected. Now you can take a look at it very easily. Let me click on here and see if the network is fast enough. So if you go to eucscore.com results, and when we scroll down, you'll see that I have many of these test results in here. And let's start with something that I just did recently. Parallels, they asked me to do a comparison of what the user experience is when, well, redirecting file access using their technology. And you see the activity down here. This is the difference between a native AVD environment compared to being accelerated by Parallels ROS. And you'll see that on the left side with Parallels ROS, it's going to be terminated. It's going to be done really quickly, while on the right side, it's still collecting all this information. And so we have these activities, what's going on. That's the real user experience. It takes a minute longer until the drive was scanned. So that is one of the things that they wanted to find out. The same thing is true. I did similar tests for control lab using FSLogic's profiles on NetApp versus on standard Azure files. And the idea was to find out, do we get a better profile load and storage performance with NetApp compared to standard Azure files? And yes, there's like a 15 to 20% without any optimization. We were able to see that that there is a better performance by copying, creating files in memory, and then writing it to the profile and seeing what the performance is. In the background, if I zoom into that, you see more details. So you see that I have the control app console running in the background so that you also see what the monitoring side of the house sees. But here we see what the end user would be able to see. So you see the HTML5 player. It's fascinating because it shows us, hey, all the telemetry data overlaid with the videos. And you see it's color-coded. Yellow on the left side, red on the right side. And down here, the telemetry data is color-coded as well. So that is the idea behind that kind of analysis using the this HTML5 player. I did the same testing for VMware, and if you scroll down, and like I said, you can all look that up yourself easily. You see there's VMware stuff that I tested, Vision Frame, then there is Frame plus AWS, Frame plus Google, thin clients and Microsoft. So these are the tests that we run with IGEL. But let's go back to the presentation because I have two interesting examples. Here's my slideshow. Good. So I'm back to that. So if I go to the next, this is a test that Ruben and I did well, we connected to Azure Virtual Desktop to a GPU accelerated machine from an IGEL client. Now, if you run the video, you see the difference immediately. On the right side, it's stuttering massively. When you look at the telemetry data, looking at it from a monitoring standpoint, you can't see the difference. Why is this happening? And it took us a while because I did that first in my lab. And good practice in scientific testing is only if you can reproduce it. It's true data. You need to verify it. So Ruben did the same test, and he said, I cannot see this effect. And we were like, wow, what's happening here? In the end, we found out he was using UMS to configure the thin clients. I didn't, because I only had 3 thin clients in my lab. I configured them locally. And the frame remoting protocol requires a pass-through of the GPU of the client to the Chromium browser that's built into the IGEL OS. Now, unfortunately, there was a bug that did not allow, even if I thought this setting was made, it was not applied. We reported back that bug. It doesn't exist anymore. But we ran into this bug, which means that if you deployed at the time IGEL thin clients and you configured them manually, you would get that kind of experience. Even though the backend and the network were trying to deliver the exact same thing, but the client wasn't able to keep up. That was the simple reason for that. So don't blame any of the vendors. It was not a real problem. It was just one thing, one setting that didn't work as expected. And here is the other example. Like I said, on the right side, you have a GPU accelerated machine, and it's massively slower than the machine on the left side. Yes, the left side is also GPU accelerated, but I have comparisons where I have a CPU-only machine that outperforms easily the GPU-accelerated VM here on the right side. The reason is that I created code like many developers 15 or 20 years ago did it. It's not multi-threaded. And you cannot put it on a GPU that only performs well if it can do things in parallel. So they have many, many cores. If you cannot use all these cores in the GPU, the CPU is able to outperform an individual core on the GPU. Now, the CPU is not smart enough to find out, oh, I can do that much better than the GPU. It's very simple. The OS tells the CPU, look, there's a GPU. If there is any algorithm like graphics, you give it to the GPU. Okay. So the CPU is only the orchestrator. The CPU doesn't know that the GPU is not good from a performance perspective. That's something that you need to know. This is the myth that I can prove is correct. There are applications that are slower when using a GPU-accelerated VM. Fascinating. And that brings us to what is important for us humans sitting in front of a screen. So our nervous system is number one. How long does it take to respond a human? Typically, it's 150 to 300 milliseconds. Only if you're a Formula One driver, you're faster. Or if you are a professional drone pilot, like flying drone tournaments. This is like the qualification for that kind of people. Their response time, their reaction time is so fast, but it says here, varies with age. If you are into competitive drone flying, you got to be young. If you are 30 years or older, no way. You will not be able to compete with the younger people doing that. So, but you see, 15,000 to 30,000 kilometers of fiber optics. So, okay, we're good on this side. So we don't need to be too fast. Visual system, different. We need at least 24 frames per second so that we regard something as motion instead of individual frames. So this is how our human eye works. Most refresh rates on desktops are 60 frames per second. Good, so we're good, except when you are Thomas Poppelgaard, who is using, like for everything he does, he's using headsets. And headsets have the challenge that you include the peripheral view. And our eyes are a lot more sensitive in the peripheral view. It flickers up to 500 hertz, so much faster. That was a matter of survival for us, not for us, but for those people who lived thousands of years ago when the saber-toothed tiger wanted to attack you from the side. You wanted to see that kind of movement. And if you're looking straight at somebody, 60 frames per second are more than enough. But from a peripheral view, no, that's not the case. This is why people get motion sick if the refresh rate is not high enough. Because if you're moving your head and it's flickering in your peripheral view, it's like drinking too much alcohol. So many people just vomit. And that's an interesting effect. So this is why these people are complaining about when the refresh rate is not high enough. So it should be at least 90 hertz or 120 hertz, but only if you have this peripheral view. And the ear. The ear is very sensitive, more than the human eye. So if you look at that, between the two ears, it goes down to 10 to 20 milliseconds. This is why we can hear direction. If somebody is talking behind us or somebody is talking from the side, then the sound goes around the head, and this difference, this is something we can hear. and we can process. So this is why our ear is more sensitive than the eye. But in most cases, the middle, the visual system, is our reference. This is what we need to know. And hey, they found out more than 150 years ago, they found out that, well, having multiple frames quick enough, they give us the impression of an animation, of motion. And that is when they found out, oh, it's like this 24 hertz, the 24 frames per second when it all starts. And response time, same thing. If it's only a tenth of a second, everything is fine because our nervous system cannot go faster. It's within this 60 hertz range, more or less. No feedback is required for users. It is a natural thing. 1 second, okay, the user interaction still stays uninterrupted, good. But you can feel the lag. 10 seconds, you better show the user that something is still going on. So, and this is what I said earlier. It's not the video games, it's the lag. I had an interesting, I did my PhD thesis in computer graphics and graphics remoting at the Fraunhofer Institute for Computer Graphics. And at the time, they were experimenting with head-mounted displays and with virtual realities. And what we found out is that after a full day in virtual reality, those people were not allowed to drive with their cars anymore because the human brain adapts to lag, believe it or not. So what happened to these people? They were a full day under this, the VR device, and the brain adapted to the lag. They took it off. They were trying to leave the room, and they ran into the door because it came too fast. Reality was too fast. Now, if you sit in your car and you drive your car and reality is too fast for you, not good. But this was an interesting learning for us that the brain adapts so quickly within a day. So that means if your user says in the morning, oh, performance sucks, and you ask him in the afternoon, he may say this, oh, it's better now. No, your brain adapted. We didn't do anything. So be very careful with these things. But gamers, they are very sensitive to that, and CAD/CAM designers are as well. And there's even military standards for that. That is interesting. The US military is very, very clear about that, where the limits are. So there's an entire book about that kind of delays or lags that they're willing to accept. And you need to take into account what kind of user persona you have in front of you. Like I said, a CAD/CAM designer will respond a lot more sensitive to lag than a task worker. For a task worker, it doesn't matter if the information is there like half second later. For somebody interacting with a 3D model, that makes a huge difference. So, let's come to the findings, like the last a couple of minutes. EUC market changes. There are two things. Number one is there are so many vendors who change their business model now, while other vendors, they see that as a huge opportunity. And our market starts, our EUC market starts being mainstream. We've been waiting for that. I've been waiting for that my entire career. But now it's happening. But what does that mean? It means that, hey, we're not talking about a maximum target audience of 100 million users globally. Now we're talking about a much larger number. Just to put it into perspective, Microsoft says that they have roughly 1.5 billion Windows endpoints out there. Half of them is consumers, and half of it is enterprise users, DEX. Digital employee experience. So this is like 750 million end users. This is our potential target audience. And now, with Windows 365 and all these technologies, we are trying to address exactly that market. But those people that we address now, they don't come from the EUC space. They have no idea what a remote desktop is. They don't know about lag. They don't know about any of what I just said. They just want to have a desktop that gives them a good user experience. End of conversation. It's our job to provide that and use science to find out what is the good performance that users want to have. What I do more and more, I run these kind of experiments that I showed you, like the side-by-side comparisons in end-user companies, and I record a before and after setup. Like, okay, this is what you have today, sometimes even physical machines. And, oh, you're planning to migrate everything, let's just say Windows 365. Okay, let's just do a POC and find out what the end user experience is. And then show those videos to your end users. Is this acceptable for you or not? And this is go away. This is an interesting thing because end users and decision makers, they can deal with videos a lot better than they can with just data. If you just give them abstract reports, and Nicola said that in her session, yeah, people won't read that. But they watch videos. They know how to compare those videos. And the other thing is that we're running into an interesting new era that our technology, EUC technology, is accepted at places where it was not accepted in the past. Like, for the first time, Develop 3D did a report on how good GPU-accelerated VMs in the different clouds are compared to physical machines. And just let me click on that because it gives you an idea what Ruben and I did, because this is something that I did together with Ruben Sprout. And he uses exactly the same thing that I did. You see, it's AWS. We did a lot of AWS testing, Azure testing. Let's go to AWS and just click on one of those and see what's happening. So now you see different tests, different previews, and now running this, and you will see it looks familiar if it loads. Yes, it does. So this is why Ruben wanted to be able to do that manually, because he started rotating all of that. That is not simulated. This is Ruben doing it and using my telemetry collector and the video recording to collect everything. And Greg Cork, who wrote the article, we asked him, hey, what is the refresh rate that your CAD/CAM users need? Could they differentiate if it's 30 frames per second or if it's 60 frames per second? And he said, no, absolutely not. They don't care. 30 frames per second is enough, but lag. If they rotate this object and the mouse and the object are not in sync, they get really, really mad at those who give them those desktops. So very, very clear statement. What really matters is lag and not the refresh time. Take a look yourself. The other thing is we did a lot of testing around the VM types and remoting protocols. And like I said earlier, it is not a matter of the remoting protocol. It's a matter of combining the right VM type with the right protocol if you know what kind of application type you want to deliver to the end user. Did you ever try to find out when you are a consultant and walk into a customer, hey, what is the typical type of application you have? There's death silence on the other side. We have no idea. Okay, so I go through all the applications and I get the overview of if it's CAD applications, if it's media applications, if it's like the persona, I'm trying to find out what kind of persona it is we're talking to. And Ruben and I, we put together that kind of matrix, and we have multiple of those. And you see, not only using EUC score, but also using log NVSI and other benchmarking tools out there. But the thing is that if you look at this here, and I don't want to blame log NVSI for that, because this is a GPU accelerated machine. My workloads are optimized or designed to run on GPU accelerated machines. So here the price per VM, price per performance, shows a different color coding compared to log NVSI, because in log NVSI we were using a workload. Their workload was not designed for GPU. So be careful what kind of benchmarking tools you're using for what use case. So that is one of the things. And like I said, the quality criteria to convince people not to look at performance counter on the host side only, but use those quality criteria that I described earlier. This is the biggest challenge. So I was the only person who did it in the past. And I asked Scott Manchester, who is head of the RDS team, like the team that's responsible for Windows 365 and AVD in Redmond. I asked him, why is it relevant now to look at that kind of criteria? And he said, very simple. In the past, our target audience was IT professionals. And they didn't really care what ended up at the end user. And I said, whoa, wait, you did not care? Oh, he said, we did, but our target audience didn't. So if the performance was not good on the end user side, we blamed it on the networking team. Or we said, add some more CPU resources, do something. We were never able to measure what the quality was at the end point. Today, things are changing because Windows 365. Now, customers reach out to us who don't want to have that mumbo jumbo. They just want to have a good performance. So suddenly we care about the end user experience, and that's a game changer. So that is the interesting part for me, that my science that I do since 10 years now, that it becomes relevant. In the past, it was just a hobby. Now it's more like a business. So that means, if you want to know more about that, if you want to run that kind of tests yourself, just send me an email. For community members who are willing to publish the results, everything is completely free. I have 2 developers working on these things. It cost me a 6-figure number to get that all together that I paid over the last years, plus all my work that I put into that. But like I said, I give it away for free for those who are willing to publish the results. And this is something I want to show you at the end. One of my customers, they wanted to know what the difference is between HDX in a custom environment, like they're interacting with the application, compared to when a home user, work from home user connects. On the left side, it's a work from home user. And this is in their local environment using HDX. And for the first time, this is a group of city planners in a city, in a medium-sized German city of Ulm. And this is the experience that the end users get. And now they can take this video and bring it to the end user and say, is this acceptable performance for you? If it's acceptable, we can give it to you. You can access this from home, but you cannot get better than that. This is what you get when you are on site. If you need that, you need to come in. Very easy. So they bring it over to the end user and bring them into the project at a very, very early stage. And this is what Nicola said in her session. This is critically important to have that, well, the user being part of that at a very early stage. I I didn't know that these cities have professional drone pilots. All the data was collected by drones flying inside and outside the cathedral with all the textures and everything. The first time when you realize that it's now, well, rendered is when the drone is flying through the wall of the cathedral. So they're using this data to do like crazy stuff. And it was fascinating to see that in public administration, a German public administration, which is notoriously slow when it comes to new technologies. With that, thank you very much.